after meeting a long time, I am publishing my next lecture, that is shear force and bending moment diagram. So here right now I am solving the 7 examples and by easy and quick method. Let us solve first example of simply supported beam. Just I am giving point load over here, right? So what about the reactions? It's phi and phi, right? Now let us draw shear force. Here I have reaction 5 kilonewtons, so it will be shown by vertical line, right? So what about the shear? Shear is changes from 0 to 5, right? Now in between A to C we don't have any load, so it will be represented by horizontal line, right? Again we have a point load of 10 kilonewton, so it is 5 minus 10 and finally the value is minus 5, right? So minus 5 is over here. In between C to B we don't have any load, so it will be represented by horizontal line. Again we have a reaction of 5 kilonewtons, so again shear is changes from 5 to 0, right? So this is our shear force diagram. Now what about the bending moment diagram? This support is hinge support and this support is roller support. They don't take any type of moment, right? So moment at A and moment at B both are 0, right? Now what about the moment at C? The moment at C, that is phi into 2 and that is 10 kilonewton into meter, right? And the moment is clockwise, right? And for this you can refer my lecture of positive and negative bending moment diagram. This is simply supported beam and the load is downward, so definitely your bending moment diagram is positive and bending moment at D is 10 kilonewton into meter, right? Now let us solve the next example, right? Here the total load is 10 into 2 plus 2, that is 4, that is 40 kilonewton, that will be distributed among two supports, right? So the reactions are 20 and 20, right? Now let us draw shear force diagram. Here we have vertical reaction, so shear changes from 0 to 20, right? And we have it will be represented by vertical line. Now in between A to B we don't have we don't have any other load, only the UDL is there, right? So UDL will be represented by the inclined line, right? So here the shear is changes from 20 to the minus 20. How it is? 20 upwards minus 10 into 4, that is UDL 20 minus 10 into 4, that will be the minus 20, right? Again we have plus, that is positive 20 over here, so finally the value is 0, right? Now let us do the bending moment diagram. Here same way these two supports don't carry any type of moment, so the moment is 0, only we have to determine moment over here at C. So how to determine the moment? Let us see. So moment at C, that is 20 into 2 clockwise minus 10 into 2, that is into 1, that is anti-clockwise moment. 20 into 2 clockwise and 10 into 2 into 1, that is anti-clockwise, right? So the moment is 20 kilonewton into meter. 20 into 2 clockwise minus 10 into 2 into 1 anti-clockwise, right? So finally the moment is 20 kilonewton into meter. Again the diagram is positive because simply supported beam with the downward loading condition, diagram is positive and it will be represented by parabolic curve, right? So this is 20 kilonewton into meter, right? Now next, cantilever beam, right? Here how it will deflect? It will be like this, right? So what about the moment generated over here at free support? The moment is clockwise and resistive moment will be the anti-clockwise. Now what about the value of moment? The value of moment is let us determine the same moment at A, that is 10 into 2 into the perpendicular distance from the CG of UDL, that is 1 meter, right? So the value is 20 kilonewton into meter and it is anti-clockwise, right? Now let us do the shear force diagram. Here the value of shear above this line diagram is positive, below this line diagram is negative. Here the value of shear is 20 kilonewton, so shear changes over here from 0 to 20, vertical line. Now in between A to B we have UDL, right? So SFD under UDL, that will be represented by inclined line. Again, the shear changes from positive 20 to 0, right? 20 minus tan into 2, that is 20. So finally the value is 0 and the diagram is positive, right? 20 minus tan into 2, that is again 20. So 20 minus 20 is 0 and the diagram is positive, right? Now let us do bending moment diagram, positive and negative, right? Cantilever beam under downward loading condition, the diagram is negative. For this, you can refer my lecture of positive and negative bending moment diagram, right? What about the value of moment over here? That is 20, anti-clockwise in nature, right? So negative. Again, this is covered by UDL, so you have to represent it by the cubic curve, and the value and the bending moment is negative, right? Now next, so here again we have a cantilever beam with a downward loading condition, right? And what about the deflection? Like this. So due to deflected shape, what about the type of moment? Moment is clockwise, so resistive moment will be the anti-clockwise in nature, right? If 10 kilonewton is over here, then reaction over here is 10 kilonewton and the moment is 10 into 1, that is clockwise in nature. So the resistive will be the anti-clockwise, right? 10 kilonewton into meter. Now let us draw the shear force diagram. Upwards, 10 kilonewton upwards. Again the shear at A, that so due to the point load you have to show the shear by vertical line. So shear changes from 0 to 10. Again in between A to C we don't have any shear, so it will be represented by a horizontal line. Again 10 minus 10, this point load, so finally the value is changes from 10 to 0, right? And the diagram is positive, right? Now next, so bending moment diagram. Bending moment diagram, again above this line positive, below this line negative, right? And what about the value of moment? Value of moment is 10 kilonewton into meter, and it is anti-clockwise in nature, right? So the left side anti-clockwise is negative, okay? So 10 kilonewton into meter and the value of moment is negative. And what about the moment at C? That is minus 10 plus 10 into minus 10 plus 10 into 1, right? So the moment is minus 10 plus 10 into 1, minus 10 over here and 10 into 1 over here clockwise. So moment at C is 0. Again C is free and B is also free and they don't take any type of moment, right? So the value is 0 and the diagram is negative in nature. Now let us apply point load over here. Now same way, the moment at A, that is tan into 2, that is 20 clockwise. So resistive moment will be the anti-clockwise 20 and the reaction is 10 and 10 downwards and 10 upwards over here. Now let us draw the bending moment diagram, right? Sorry, shear force diagram. Positive above this line, negative below this line. Over here we have 10 kilonewton, right? At point load, shear changes from 0 to 10, right? In between A to B we don't have any shears, represented by vertical line. Again 10 minus 10 is 0, so shear changes from 10 to 0 and the diagram is positive, right? Now next is let us draw bending moment diagram. The moment over here is minus 20 and again left side anti-clockwise is negative. So bending moment diagram for cantilever beam is negative, right? So above this line positive diagram, below this line negative diagram. Here the value of moment is minus 20 and again this and B and is free and it will not take any type of moment. So the value of moment over here at B point is 0, right? So bending moment changes from minus 20 to 0 and the diagram is negative. Now let us apply moment over here at B, right? 10 kilonewton into meter. We don't have any shear, only moment, right? If anti-clockwise moment is over here, then resistive moment will be clockwise, right? So 10 anti-clockwise, 10 clockwise, right? Now let us draw shear force. To have any shear over here, we don't have any shear, right? So no shear, only the moment. So let us do bending moment. So for the bending moment, this one, let us take a section over here. This is the left part, this one is the right part. So the left side clockwise and right side anti-clockwise, right? Left side clockwise and right side anti-clockwise, and the diagram is the positive diagram, right? Because we have left side clockwise and right side anti-clockwise, that creates the sagging shape, and sagging is positive in nature, right? So the diagram is positive. Okay, for the same you can refer my lecture of positive and negative bending moment diagram, as well as sagging and hogging bending moment. Now next and last example. So here for the simply supported beam, here I apply moment over here at center, right? So the reaction due to this moment is downward over here and upward over here. So how it is, right? 10 divided by 4, that is 2.5 downwards, and 10 divided by 4, that is 2.5 upwards, right? So reaction due to the clockwise movement will be balanced by anti-clockwise couple of forces, right? How it is here, this couple, see how this couple is? This couple is anti-clockwise in nature, yes or no? As we have a clockwise movement, and that's why here the forces are, the couple is anti-clockwise, right? Because the clockwise moment, that is balanced by anti-clockwise couple of forces. That's why I have applied reaction like this, right? Downward over here and upward over here, right? So here the distance between these two forces is 4 meters, 2 plus 2 4, and here the reaction is 2.5, here also the reaction is 2.5. and what about the moment is anti-clockwise, right? Now let us draw shear force diagram, positive and negative. Here the value of shear is 2.5 negative, and here the value of shear is 2.5 positive. Do we have any shear in between A to B? We don't have any shear. Okay, so we have only two values, one is minus 2.5 and another one is positive 2.5, right? So shear changes from minus 2.5 to plus 2.5. Negative over here, positive over here, right? Now let us draw bending moment diagram. What about the bending moment at A and B? We don't have any moment at A and B, because at hinge support and at roller support, they don't take any moment, right? They have only one reaction and two reaction, no moments, right? So moment over here at A is 0 and B is 0. Now what about the moment at C? For the same, we have to determine moment at just left of C as well as moment at just right of C. Consider this yellow point, right? So and let us determine the moment over here at just left of C, right? What about the moment? See, this is anti-clockwise in nature, minus 2.5 into 2, right? And so moment at just left, it is minus 2.5 into 2, it is minus 5, right? So moment changes from 0 to minus 5, right? Now what about the moment over here at just right of C? Let us determine the same. At just right of C, at just right of C, the moment is, see, what about the type of moment? Again it is anti-clockwise in nature, but right side anti-clockwise is positive. Okay, left side anti-clockwise is negative, but right side anti-clockwise is positive, right? So the value of shear at C, value of bending moment at C, at just right of C, it is 2.5 into 2 is 5 kilonewton into meter and positive. Again value of moment changes from minus 5 to plus 5, right? And bending moment at B is 0, roller support, don't take any moment, right? So this is about, my dear students,